I heard that with wider knowledge of the variety, we can look at the schedule and you see that what can have profit. Anyway, just a quick uh, introduction to Eric and friends. Just brief. Yeah.
Welcome, everyone.
There's a feeling to us to feel because if you try for a reading and the thing and maybe it's really very hectic, probably a bit stressful for you. In the past 2 weeks, we need to have a session, but because really this event, um, more of an expanding of what we are usually doing, and what we do, we will basically
Then is mostly new from the past and usually can get later from the time when switch the changing software to keep his talk from the you have 30 minutes but until Dr. Patron comes pause here.
yeah, you know, I think,
Yes,
I enjoy the information, you know, I saw, I have just in time. If you get,
therefore,
yes. Therefore, I have to keep it to someone. Because to look up and I'm very happy to say, activity, not only for this, and it's easy to that, so the other is just amazing. And it's the best thing about so this is that's a proper different than anything we can say. We starting I think the mission. And this is the one in the middle because the list just to start the problem with time reduction. Because it is first going down station to be visiting the time in the back of the points the list of starting with the problem to be the but I need to be because to be that's why we are very happy to collaborate with our story. We can we can solve it for the development of the and then we have to in the satellite in the collaboration with the United States and this is the seven countries and military one of the revolution and one of the revolution that we have the military revolution, which is a whole institution. And so the currently in the collaboration with was Japanese other organizations. And the ministry of the environment and the national ministry of environmental studies, we have the two greenhouse gas emission declaration satellite in Malaysia using the 2009 It's a force of greenhouse gas emission satellite and also the sort of the and also the distribution on the water side, so we have the one satellite, DMWG, and the prevention is NASA. We have the three here in and also find the GP and media and the use public distribution mission. And the right mode is part of the mission and the so, yeah. Some of the know and the public notice, but some of the websites and the specialization don't know that it's a full version of the optical camera. And so can be monitored maybe increases uh, every 2 days regarding income bands and we can see something. Controls so the data satellite in the rescue is therefore the currently in the collaboration with NASA, in total is operating 6 satellites and this year, this fiscal year, so we expected around launching in the next satellite. But because of the failure with the launching in place, we have to postpone in the launching of the next satellite. But it will be coming in the next fiscal year, starting from this year. And we have the joint mission with the ISA, and it will be also launching in this year. And also with this is the success of the website and the really of the DW. So, not to providing the observation that one is the key is how to providing the information, not only for the data itself, because the user that do not care, does not care about the data itself. Instead, they would like the information. Especially when we try to promote this kind of information to the community agency in the user. We definitely needing this kind of nicely visualized map in simple data itself. Therefore, by using the GW and GP3, they will do extremely controversial in Japan and with other countries. Therefore, these just interpretation, they will change. But if you compare with what actually participation, previously. So, it's a really quite funny statement. Not even in our it's a framework, in the sense it's reduction. Considering what is easy. And other responsibility, responsibility is that's fine with the global agenda. They're very happy to providing flexibility. The idea of really starting to speak currently the ability. And also the government to not only hold to providing the kind of information, but also the technical information. Because information areas is already operating since 2014 to the 13. Therefore, the results are more than 9 years later of the global manufacturing convention. Therefore, this very big time is you have something happen. You can easily compare with previous one and time situation. So this kind of the effort is very important. And also the we find that someone is a innovation we can familiar. It's very calculate. This is a very big detail, but again, so basically, everybody in this kind of element, especially the even in living to classify why do we have the contributing how to contribute so we have to put it in the activity for those and the activity the source we can try to mark it. That's so basically, welcome to Karen. People have been making how to integrate the data, how to transfer, how to maximize the using. Culture or some drought and deforestation and so on. We definitely need global data, and also not only for the global data, but also the very good modeling and simulation for the future. Therefore, only by using the one specific satellite is not enough to provide some data. Therefore, we have to integrate in several satellite simulation information, simulation models, and to providing the information not only for the current or past, but also the future. So this is also always to have the discussion for how to reducing the greenhouse gas from the world, because by using our two satellites, we can, in the collaboration with Ministry of the Environment, we providing the information of the world and the around the 2020 time frame of the plan. That's 2019 or 2020 time frame. We found that it's over the 400 ppm. Okay. Yeah. Okay. And how to full screen is PDF. I don't know. Yeah. Yeah.
Okay. Never mind.
But you can see this is dying to over the 400 ppm. And it already happened around the world. And still the very increasing the number of the average of the carbon dioxide. This is northern sphere. So there are annual variation because in the summertime, sorry, in Thailand, I don't know summertime.
In our yeah,
Tropical region, in the, especially of the upper high latitude area, it's a very big in the vegetative activity. Therefore, the carbon dioxide is reducing, but in the winter time, it's increasing. Therefore, it's very big. You can see that most of the area is all over the 400 ppm now. So you may have some question. Why we don't have the Indonesia or some area? Because of the cloudy condition. Because this cannot be observed in the summer area. But you can still understand how increase how what is the number of the increasing inside carbon dioxide. But one of the issue or challenge to the monitor the carbon dioxide by the satellite is we can detect in the current density of the carbon dioxide in that location. But it's different from the methane emission because the methane gas is emitted location is almost the same as to observed area. But the carbon dioxide things, it's easy to go in other places. Therefore, we have to know the climate weather condition because if the high wind, the CO2 will be emitted, for instance, here, but it's detected here. So it's one of the discussion. How to, where is emitted? Every country says, no, we don't emit it. It's coming from other country. Therefore, the simulation is very, modeling is very important with wind information and this kind of information. And it's not really directly related to this total country, but it's very important for us to understand the global change, climate change. Because this is the Arctic area in the 1980s. This is one of the biggest record for the satellite. Since the 1980s, we have the continuous observation of the sea ice extension in the Arctic area. And this is, of course, it's not only the single satellite, but several more than 10 satellites. But we can have this kind of record since the 1980s. And in the summer season, in the 1980s, still most of the polar region, most polar region is covered by the ice. But in the 2012, it's a smallest minimum record. We can easily compare with this size and this size. It's only the one size we have in the summer season. This is the latest smallest minimum record. And then even in 2020, it's a second record. And shrinking is continued up because of the temperature raising. It's also because of the connection with increasing the number of the carbon dioxide. Therefore, it might be very dangerous situation for the world to increasing the number of the carbon dioxide and to increasing the number of the temperature. But sometimes it's also on the other hand, opposite side, it's also very useful to using this opportunity because when to China or Japan or Korea would like to go to the Europe by ship, the cruising only the cruising passengers go through the all the way to go down to the South Africa and go up to the Europe. But if we have this channel, the route, things of the route is only the one side. So it's a very good opportunity to go to this way if there are no sea ice in the summer season. So this is a good thing of the climate warming. But currently we cannot use this path, even if there are no sea ice, because we can easily understand this is the Russian side. So cannot allow to go through now. And also this is also very good for these regions. Well, not only for the high or Southeast Asia, but also the East Asia, because of the too much dust or air pollution. This is a yellow dust from the summer in China or west. And also the forest fire or something is happened in the areas. So by using the geostationary satellite for orbiting satellite, we can easily differentiate in the cloud and this kind of. And by using this kind of information, we can just create the one of the people because it's very dangerous for the people of the place. But again, this is very challenging to discuss because we can show that this is information, but cannot say who initiating from who. Yeah, it is in Indonesia. We already discussed. The Indonesian people say, yeah, it's coming from the Indonesian. but owned by the different companies. Therefore, they have some therefore, it's very difficult. But beginning, you have to use this kind of information. And as I already said, it's very important to integrate use of the satellite data with models to providing the information. Because which I already showed is only the current situation. But we didn't really know what will be happening in the next. Therefore, it's very important to have the satellite data with information and models. The models should be integrated in the land, airs, and oceans, and other models, and providing the information. And by using the satellite data as input data, and also the satellite data can be used in validation tool to improve the models, because modeling can be done by using the historical data and to verify by using the satellite-based data with models. So to do that, but through such kind of activity, we can improve the models and to providing the more good forecasting and the prediction. Therefore, the continuous observation is very important. And some of the countries, we also providing in the hourly precipitation data with a 10-kilometer grid. So this data is almost real-time data for providing the user in around the countries. Like the Philippines and other countries, in the island country. Yes, very important to have this kind of data. Yes. Because you can understand most of the weather for the Philippines or even the Japan are affected by the weather on the ocean. It's the same in Taiwan. Therefore, especially for the tropical cyclone or typhoon, it's coming from the ocean. Therefore, if we would like to have the emergency response or preparedness, we definitely have to know the more precise information on the ocean, especially for this kind of the extreme precipitation event. Therefore, the JAXA will be collaborating to providing the information to this kind of map information to the Pacific Island countries, and so they can use this data for the typhoon warning or cyclone warning or something. But since one of the issue is connectivity of these countries, because of course we can reach them, but only the big island country can be supported, but not some small countries. And also this kind of precision information, another value is to providing the satellite data with ground observation data with a map, and to providing the flood runoff alert, flood early warning for the flood. Because of course this is a collaboration with ICANN and the ADB with the UNESCO. We providing the hourly precipitation data, and the combination with the runoff models, the improving is flood early warning in this case Pakistan, but also we have the same kind of collaboration activities with Bangladesh, Vietnam, and Philippines. So especially for in Bangladesh and Philippines, they have the difficulty to the enough information of the precipitation, because because of the transboundary, it's the same type, because it's a transboundary river. So you can get in the data in your country, but cannot, it's very difficult to getting the data in the upper area. So by using the satellite information with precision information, we can to creating the improvement in the flat alert early one. Okay, as always, I speak too much, so skipping some of them here. As the quickly to mention in the disaster. Disaster is also the one of the issue, and the satellite data is very variable to monitor in the disaster, especially this kind of the very big earthquake. So in Turkish case, we providing this kind of the satellite data, but still the one of the challenge is satellite data itself is like over the several gigabytes. It's a small one. But this case, when we try providing in the cozy resolution data, one data is maybe it's for the Apan people is still small, but it's about 60 gigabyte per scene. Always, it's very difficult to trust. Yeah, it's very difficult to trust such kind of data. But by using such data in the fault, we can detect the fault and also the building damage assessment. Same as in the not case. In our New Year day, we have the very big earthquake in Japan. We providing the emergency observation by using the LS2 and to our ministry to creating this kind of map. And also the coastal line is changing in Japan. Okay, skipping this one and quickly mention about some of the collaboration in the agriculture. We have the currently 3 projects under the Asian Pacific Regional Space Agency Forum and led by the India ISRO, JISA, and VNC, Vietnam National Space Center, and providing the monthly agrometeorological information provision to providing the rice outlook information. And second one is the rice planting area mapping. And very, very new one is the methane emission monitoring. To reducing the methane emission from the paddy field, we would like to monitor the water condition in the paddy field. Yeah, so the first one, led by the ISRO, we creating this kind of map by using the 3 agencies, several agencies information. And this case is the ISRO and JAXA, to creating the precipitation anomalies and others. And just to using the several satellite data is one of the challenges to compare with the different satellites. And planting area information, we also try to collaborate with JISA and to compare with our map with the JISA map. And again, to promoting this kind of information, user, especially for the agriculture ministry, would like to have the only information. Therefore, we just by using the Google Earth engine, to put in all of our satellite, LS2 satellite data, and user can easily just visualize it in the planting area map on the Google Earth engine. And also recently in Cambodia, some country, we just to try to collaborate in the machinery information from some company, because they have the planting area information by using the machine and also the user information. Therefore, we just to try to collaborate with them to improving our estimation. Because in this case, we just using the AI technology. But to using the AI technology, we needing the big training data. But by human, it's very challenging. So finally, just quickly mention and methane emission, because of course in the paddy field is paved by the water, but if we continue to pave the water, they are very big methane emission. Therefore, recently, AgWG is deployed to reducing the methane emission 30 or 40%. So to justify such kind of activity, we definitely need to know in the water condition on the party field. But by using only the ground-based system, it's very difficult because it's costly. Therefore, the try to have the satellite-based data and to compare with the satellite-based data with the ground-based data. Therefore, we just to starting this kind of collaboration with the various countries, and we recently also to discussing with FIRSA. So this is very classical ways that putting the water level monitoring systems with the satellite observation. We just to continue to do this kind of work. Therefore, it's very good opportunity to collaborate with the consortium. Okay, thank you very much.
Thank you, Dr. Sobue. Any questions from the floor? One question. Yes.
Thank you, sir. You're talking about the spread, maybe the low level of the atmosphere. What about the troposphere? So what's happening? Do you have any monitoring systems?
Okay. You mean the more high latitude? Yes, and so there are some ways to monitor. Because it's a different technology, like a solar occultation methodology can be monitored in the more upper. Yes.
Thank you.
Any more? Yes.
Because from your slide, we see that you use aeroplane data to know where is the water situation in the farm field. And because that is aeroplane, the penetration is so strong, so you can know, I mean, under the vegetation, the information under the vegetation. How about different band? C band, is that possible for C band? We know X band is not possible, but how about C band?
Yeah, thank you very much. Question. Yeah, and unfortunately, C band is almost same as X band. Therefore, they cannot penetrate. But the ISRO, India will have the S band very soon. Maybe S band is the same with L band. But the issue is polarization. We need the what polarization? Polarization and band. Yeah.
Okay. Thank you very much, Dr. Sobue. So Dr. Pagon is not here yet. So probably you have to take his turn. Okay. The next speaker will be the Dr. Ling Yu Chang from Taiwan Space Agency, and he will give a talk about what Taiwan Space Agency satellite program doing and its application platform for environment monitoring. And he will have also the training session on Thursday. So don't forget that, and don't forget to install the QGIS before you come to the session to save time, please.
I'm so happy to have this opportunity to say something of our agency, Taiwan Space Agency, TASA. And the topic that today I'm going to say is about the satellite program and the application in TASA. Okay, so the first is the position and mission of TASA. Of course, TASA is the only space agency in Taiwan. We operating under National Science and Technology Council. And Taiwan, of course, you know, Taiwan is right now is a very important player in satellite technology. And right now we are eager for searching a cooperation opportunity with others, or maybe all of you is our the people who want to cooperate with. And talk about our history. Actually, we start from 1991. In that time, we are a National Space Program Office, and then we have an NSPO. national space organization, that is a more formal organization in Taiwan for space affair in 2003. And in 2022, we have a Space Development Act in our government. So in 2023, we have TASA, Taiwan Space Agency, established. So we are only 1 year space agency right now. And of course, we have another responsibility to promote the space technology in Taiwan. Of course, we have to run a national space programs, and we also have lots of research and development project, especially with academia. And we also have to have industry promotion of, as you know, for space agency, we have to, I mean, the major responsibility of our agency is to establish satellite, and we have to cooperate with our domestic industry to help with develop a component of satellite, and hope that we have a successful satellite program. And of course, we still we also have to have talent cultivation. That means we have to have some program for our students to learn space technology with us, and then they use our future manpower. Okay, and of course we need to have international corporations. We have many seminars and workshop to establish connection with people. And of course, we run satellite component and payload and satellite applications from segment facilities. Especially, we have space exploration programs to search a different kind of technology, and we also have to have space transportations part, especially for our administrator. He is promote launch vehicle right now, and of course space policy. And this is a very brief introduction of our structures. And of course, in the board of directors, there is the auditing offices. Actually, that is the most headache one for us, because they check everything for us. Especially right now, the security, internet security is a big issue. So auditing office. And of course, we have 4 major sectors in our under Director General, for the sector of space affair and sector for project execution. Of course, there is a system engineering and the quality assurance department. They to make sure everything is good to in our satellite. And the sector of space application that is used for promote our space applications, and kind of knowledge exchanges for that is have to promote by that sectors. And the sector for technology development actually is to develop technology used in our satellite or in our monitoring. Especially for me, I belong to satellite data analysis division, and actually we are under satellite data and equipment department. Okay. Talk to here. Actually, we have I cannot say many, but still a lot satellite there already. Start from 1999, that is ocean color satellite, and then we have 4Z2. Actually, that is developed by French people. Actually, currently Airbus. Right now it's Airbus, but before that is Connect. Okay, and the next one is that Formos 3. That is weather satellite. We call that GPS RO, use radio occlusion technology to know parameter of atmosphere. Okay, and then Formos 5. That is so-called self-developed satellite in Taiwan. Okay, that is the optical satellite. And then Formos 7. That is a successor of Formos 3. It is also a 6 satellite constellations used to measure the atmosphere. Also, that is a GPS RO radio occlusions satellite system to know atmosphere parameters. And then Triton, that is a GPS arm that is used to measure the ocean wind field. That is use GPS refractions. GPS the refracted signal from ocean, and then used to know the wave height, and then to derive wind field, something like that. That is Triton launch in this year. And the next one is the future satellite, Formosa 8, that is also 6+2 constellations. And then B5G, that is communication satellite, like starting, but not that many. Okay, but only a communication experiment satellite. And Formosa satellite, that is another different kind of satellite, star satellite used to use star technology. Okay, so maybe I want to talk more deep in our satellite technology. Formosa 5, that is the first self-developed satellite. And then we have to handle different kind of components by ourselves. And the image of that satellite is 2-meter resolution in kinematic and 4-meter resolution in more spectral. And especially is the revisiting period is 2 days. So every 2 days we can take a look at the same places. And the swaths maybe not that large, 24 kilometers. And right now we have, because it is operated for 6 years already, so we collect lots of image of the world by using Formosa 5 data. So, okay, 20,000 images set, including more spectral and kinematic data over there. So all the data, we will put that in a platform to let user to use. We call that a data cube. Maybe I will mention that in the later. Okay, and because in order to handle this many of data, so we need to have a platform, not only deliver those data by file base. That will be a headache things. So we will have a platform over there, and that actually we will introduce in the later. Okay. Let everyone knows how to operate this many images with a suitable platform. And okay, of course, our Formosa 5 also is under Central Asia constellations. With this constellation, Sentinel Asia will send EOR, emerging observation request, once there is a disaster in the Asia places, and then we will help them to collect satellite images. And it's not, but in this time, collect satellite image is not enough. We especially have to deliver the analyzed result. Then, because as you know, there right now, the image is not problem, but how to develop the analyzed result is a major issue. So once we have EOR, then we will test our satellite to get the images, just like the others. Okay, and then we will try our best to get the analyzed result. For this one is oil spill cases around Philippines, and then we will because the 2-day revisit period characteristics of Formosa 5, then we have around 8 days results for the development of the oil spill. Of course, the first one is not for, the first satellite image is from SEALS, not Formosa 5, but the other 3 is for Formosa 5 because of 2-day revisiting period. So we can see the growing of the oil spill situations. Okay, the other is we also provide disaster management for earthquake in Turkey. Okay, this is the case in February. So we help them to identify where is landslide area, something like that, to see where is properly has disaster situations. Okay, this is Formosa 5. Okay, in the future, we have Formosa 8 constellations. That is 2 plus 6 plus 2 okay, optical satellite constellation. 6 satellite with 1 meter, one resolutions, and submitted resolution will be achieved by super resolution technique. We hope that we can achieve that in 0.5. Okay, the specification is written in 0.7, but we hope that we can achieve 0.5 spatial resolutions. That's it, because we in that Formosa 8, there's 2 pane images. Not only 1 pane panchromatic image, we will get 2 panchromatic image at the same time. So it is hopefully we can get around 0.7 to 0.5 spatial resolution image by super resolution techniques. And the other 2 satellite image, that is a true submitted resolution images in 0.5 resolutions. So then this is 6.2 optical satellite constellations that will be developed in the later. Of course, right now in last year, the integration and test review was passed by IKEA, and we hope that the first Formosa 8 satellite will be launched in next year. Okay, now that this is around the status of our most recent Formosa 8 satellite. And for the next one, Formosa 9, that is, of course, that is SAR image. We know that SAR image is very important because that is all, it can be operated in all weather conditions. And right now we are trying to establish 2 satellite constellation for SAR satellite in X-band. Okay, as we know, for X-band, because X-band is easy, L-band is very difficult. So we start from X-band. Okay. But as you know, maybe X-band can have very high resolutions, but because of penetration problems, so you can only see the information from the top surfaces. Okay, but at least this is the beginning. And in last year, the mission definition review was passed. So hopefully we can continue this project. Actually, I also have to develop, for my part, I developed a PSS, program and scheduling system in these SAR systems. Okay, so in the next is, okay, we are going to have to talk something of our applications. Since we have that many satellite, so we have to have application development for our environment, to monitor our environment. And in order to operate this data properly, so we need to have a platform. Because as you know, in the past, before, more normally data is delivered in file base. Okay, 1 file, 1 image, and like this way. So right now, we try to organize everything in the platform. We call that Open Data Cube. Actually, Open Data Cube is promoted by CEOs, Committee of Earth Observation Satellite. Because everyone knows that and your data have to be managed by a proper system. It cannot be delivered in file base. So CEOs cooperate is say that GA, Geoscience Australia. They start to develop Open Data Cube to manage satellite data properly. The major objective is it is established in the cloud computing environment. They have the characteristic of data warehouse to integrate a different kind of sensors together. And then because that is a cloud computing environment, so you can operate the data directly in the cloud environment you don't have to download data to your local site because that takes a lot of times. You can just operate your module with the data collected in the cube, so you can do the data analysis in cloud environment. And all the data, the specification of data has to be NS-ready data. That means all the pre-processing of the data have to finish before you put the data into your data cube. That means users, once you want to get use of the data is pre-processed. For example, for optical data, it should be surface reflectance. The data is no longer in the field with the atmosphere because, as you know, the optical data normally can be affected by the weather conditions. I'm not mentioning of the cloud. Now, even there is a fog or how to say that, water vapor, too much water vapor, it will cause your optical satellite image will be affected. That means something you observe is no longer only ground information, but also the atmosphere information will be collected. So we have to correct this image to get rid of the influence of atmosphere, and then only keep the surface information in the image. So that is the pre-processing which has to be done before user to get the image into their module. So we call that kind of data, pre-processed data, as ARD, NS-ready data. Then user can get use the data directly. Of course, all the information, all the image is provided as a service. That means when you use data cube, you write a program. The data retrieved when you set up a spatial or temporal criteria, then your data will get to a variable. Then you can just operate this variable in your program. You don't have to import file or something like that. Okay, then everything will be get easier in your NS module. Okay, so based on the framework, we ODC, we established Taiwan Data Cube that is used to manage Taiwan's data specifically. Okay, okay, I have mentioned that again. If Thursday start from 9 o'clock, we have a hand-on practice to let you know how to use these systems. Yeah, we will provide our virtual machine in Taiwan. Then you just bring your notebook, then you can connect it. We will give you account, of course, test account to try out, get a little bit try and how is the use of data cube. But it lasts for 3 hours, so that is not only a little bit time. We will tell you the needed information you need to know. Okay, so this is the Taiwan Data Cube by the framework ODC. Of course, multi-sensor data will be included in the system. Of course, for our formal set, formal set 5 and 2 data, and also lens 7 and Semina 1, 2. Okay, but for lens 7 and 8, because it's resolution, so we do not keep to collect those images, but we keep collecting in 1, 2 because its spatial resolution is 10 meters, and it covers the global in a manner of global data every 5 days. So we keep collect 1 and 2 data. Of course, those data it has been processed as AR data and then NS-ready data, and then user can extract data to do temporal analysis. Normally, we call that phonological profile to identify their ground information. And right now, our data cube is operated with the National Center for High Performance Computing. Yeah, because in TASA, we are special agency. We build setup, but we don't build the cloud computing facility. So we cooperate with National Center for High Performance Computing and then use the cloud computing environment to set up the whole thing for DataCube. But right now, we also cooperate with academic scene kind of thing. Or put something, we actually want to move something to there and see what we can do in the next. Yeah. And for TWDC and the TWCC, we got a Taiwan Computing Cloud. Okay, the official name is Taiwan Computing Cloud. TWDC and the Taiwan Computing Cloud, in there we set up different kind of cube to operate the data in different scenario. Because for the data service part, actually I have to say that different. We have two part of cubes. One is to handling the data, and the other is to handling applications. Okay, so there are this many kind of cube there to operate the data for our users. Of course, the connectivity of the cube is also very important. You cannot say that you have to log on the data cube and then you can do the analysis. That is not enough. We have to export the application to user outside the data cube. For example, some people, they only need to QGIS, and then they can have the capability to connect it to data cube and get their analysis, and then get an analyzed result back to their desktop systems. Yeah. Okay. Okay, only 5 minutes. Okay, it's enough. I only have left two slides over there. Actually, there are different kind of application developed for disasters or environment monitoring. Okay, something like that. Oil spilling and the wildfire detection, something like that. And the landslide detection, we can do different kind of things. Okay. I have said again, we're eager to search global cooperations with everyone. So hope that we have this chance to cooperate with others to see the chances. Okay, this is yeah. Actually, right now our international cooperating affair is approaching to field side and see what is the collaboration in the next. Okay, this is my presentation. Thank you, everyone.
Thank you very much. Lin Yu share any question from the floor? Oh, you want to be a member of that, right? How do you know that you know me too well? In fact, this is a very good presentation. Thank you very much. I'm from Jizda. Like Chai said, I feel so sad. You know, I don't see Jizda in the last page of your page. You know, you don't see like a corporation. You don't like me, or we can, you know.
I'm right that right away.
In fact, we can, you know, I think we can work together to exchange data or idea experience. You know, I think, like you said, you know, with this kind of work, we need global cooperation, coordination, and then we'll come to work with you. Thank you. I was kicked out already a few months ago. Last year, Jessica was chair for CEOS for a year, and then now it's in Canada, CSA. Yeah.
Actually, tomorrow, right? We will go to Jessica.
Okay. So no. Okay, that's why. Okay, we can start cooperation.
Yeah.
Okay. Any further question? No. Okay. Thank you very much. Don't forget Thursday. It's a hand-on on the open queue by Dr. Chang. From 9 a.m. Yes, of course. Not in the afternoon. Sorry. Yeah. Okay. Thank you. And next speaker, Dr. Pakon. Oh, you're not ready. Okay, then Philippine Space Agency have to come up. You're not ready. You're always ready. Yeah. Already. PowerPoint there, not. Okay, while preparing the next speaker, we move from the next session to this session first, and then the next session, Dr. Pakwan can start. Uh, Dr. Ariel Blanco from the Filipino Space Agency. Philippine Space Agency. Sorry, not Filipino. Yeah. He will give a talk about the space data mobilization in support of DRRM and food security. The floor is yours.
Good morning, everyone. So as mentioned, this is the title of my presentation. I will be talking more on the downstream applications, not on the upstream or satellite development. So I will be focusing on the RRM and food security applications. So this is the outline of my presentation, more on a little bit of introduction of the Philippine Space Agency or PhilSA. And usually we also say something about the space data value chain to highlight what we focusing on the Philippines and what we are actually the challenges that we are facing in the country. And we will briefly discuss some projects that are related to the downstream applications, particularly the DRM. So the Philippine Space Agency was established on August 8, 2019. So this year we are celebrating our 5th anniversary in August, and there's a Philippine Space Week, the second Philippine Space Week. And this is the law or the Republic Act which established our Philippine Space Agency, which is mandated to be the agency dealing with the primary policy planning and coordinating, implementing, and administered by entity regarding space. So we have these 6 key KDAs. So many of you maybe have seen these 6 hexagons. So our bureau, the Space Information Infrastructure Bureau, we are focusing on the downstream applications, management of our ground station, and distribution of our data, satellite data, and data products. So, and primarily out of the 6 KDAs, we are working on hazard management and climate studies. Of course, other applications related to this are also covered. And we, at the Philippine Space Agency, we focus on the value creation. We aim to establish a more robust Philippine space ecosystem that means supporting users, supporting developers, as well as private companies or entities in order to add and create value in space. So I will not talk much on the satellite development, but currently we are developing the MULA. So that's the satellite that is shown here as part of the upstream data infrastructure. So it will be I think 150 kilogram and 5-meter resolution. So there are scientists and engineers now working with SSTL in the UK developing the satellite, and the expected launch is around 2025, maybe last quarter. And out of this space data value chain, so we have to make sure that the data is accessible. So we have seen the Taiwan data cube, which is very impressive. And of course, we have the data, the ground station, and much of the say some bureaus or divisions of in the PhilSA works in extracting information from various satellite imagery. So that's the capacity to interrogate and analyze the data. But typically, the problem or usually the bottleneck is the impetus and resources to act on the data. We may be able to share the data sets, the data products that we develop, but we have to also ensure that the recipients or the beneficiaries are able to utilize them in decision making or in even selecting some areas at the minimum. No? And through that, we will be able to reap the socioeconomic benefits. Currently, so we have only a few sovereign satellites. So we have Diwata 2 in operation, and then we have some 10% stake with Novasar through the USD effort, no? Particularly the Starwise project being implemented by the USD's Advanced Science and Technology Institute. And of course, we subscribe to various commercial satellite systems to acquire VHR satellite imagery. And we make use a lot of the open source and of course those that are activated through the disaster charter. So those satellite data are heavily utilized by our flagship program on applications called the Data Analytics Technologies and operation services using space data. So that was, we actually continued the name of the project that was implemented by DOSDWG, but we gave it a new name now. So this basically develops some tools and systems to efficiently utilize and distribute satellite data for various applications, including DRRM, environmental, mineral applications or resources, and agriculture. And we have also a service to distribute data called the Daloy, or in our language, this means flow. And we are developing our high performance computing facility to speed up the processing and our networking and capacity building through these two sub projects, the PINAS and the CCAP. So on the disaster hazard and risk mapping, or the Dharma under the DATOS, we are focused on or working on flood mapping. We are not predicting flood or so, but maybe soon there will be some efforts or projects with Tomorrow IO to have to access the almost near real time and also projected or estimated the distribution of precipitation over the few hours. And these are actually, these flood maps or flood extents are crossed with the extents of croplands, or even at the various stages. Currently, we don't have yet a mapping of the various stages of crop growth. We have to collaborate with the, for example, Philippine Rice Institute in order to do that. And also in-house, we are also developing our crop mapping capability through the project or collaboration with the Department of Agriculture. But eventually, what we'd like to do is to cross the flood extent with those different croplands at various crop stages. We're also doing some landslide delineation of extent together with agencies such as ASTI. And in the past, for example, typhoons, so we also utilize some damage or did some damage assessment mapping utilizing SAR and optical satellite data. So in this case, we have utilized SAR data for utilizing coherence analysis, as well as the damage mapping through the normalized difference spatial correlation analysis, which we developed. And much of those disaster DRRM efforts, we activated the Satellite Asia or the disaster charter. And as mentioned by a friend from TASA, we actually utilize many images, including those from TASA, in responding to the this oil spill event off the coast of Mindoro Island. And recently, we extended the application to look at the deterioration of mangroves in areas where you have, say, previously, say, contact with the oil spillage. And now our country is, together maybe with other countries, similar condition, we are facing the drought now. So drought is a creeping phenomenon resulting from deficiency of precipitation and increased temperature. And there are different types such as meteorological drought, agricultural drought, and hydrological. The meteorological drought is being looked at by our PAG-ASA or our meteorological agency, but PhilSA is contributing much on the agricultural drought. No? And for the case of hydrological, it's mainly related to the groundwater, river water, and so on. And this impacts a lot of our economic activity, particularly on the agricultural production, which is and because agricultural drought is closely related to El Nino. In this graph, we can see that there are severe impacts in the production of, say, rice and other agricultural crops during the time when we have El Nino. No? So we have to monitor the reduction of supply of water, the surface water, as well as groundwater, and how the crops are responding to lack of precipitation and, of course, soil moisture. So in the Philippines, as you know, we are a 35% agricultural areas, and many of the Filipinos are working in the agricultural sector with many threats being faced. Based on this particular slide, we can see that there are many efforts funded by the DOST or the Department of Science and Technology in on R&D on drought. So you have the DCAF, you have the SEERD, and those are being continued by the Philippine Space Agency. During the DCAF, they were able to develop the standardized vegetation temperature ratio, as well as also utilize the combined drought indices. So this means combining, for example, the land surface temperature with the vegetation health through NDVI, as well as some measure of the uh, paucity or abundance of vegetation or precipitation. The objective is to have an early warning system, and later on for forecasting the drought extent and severity in various places in the country. So currently, PhilSA is doing more extensive assessment of the performance of these indices, the SBTR and CDI, and also integrating soil moisture in drought forecast. And of course, supporting the national government agencies such as the Department of Agriculture in responding to the drought zone. So this slide shows the precipitation index, the standard just precipitation index, the VHI, or the vegetation health index, as well as the locally developed, the standardized vegetation temperature ratio. No? Also utilizing the NDVI and the land surface temperature. So we utilize this SVTR to forecast say the extent and severity of drought or the progression of drought over the next say 6 months. But this map shows for the next 5 months now. So this was produced or released in I think October 2023. So you have November, December, January, February, and then March. No? Some areas are shown to have say changing condition in terms of from normal to maybe watch or warning or alerting. So this tags provinces with more than 50% agricultural areas that will be affected by the drought. No? And these are distributed to various local government units to assist them in preparing. No? So from those particular, say, STBTR forecasts, these are actually combined with some other condition index or condition assessment for the 2-month period to produce agricultural drought outlook. No? And these have the following categories. You have developing, ongoing and likely to intensify, ongoing and likely to continue, waning, and ending. And there are also suggested response to be undertaken by the Department of Agriculture together with the local government units. In the Philippines, so more on agriculture, we are actually suffering from inflation, high prices of agricultural commodities, particularly rice, particularly corn, and many other crops like onion. So there's a initiative being led by the NEDA, or the National Economic Development Authority, to look at how we can possibly improve the mapping and monitoring of those agricultural commodities. No? And as part of our datos, we have the space data and information for advanced agricultural knowledge and applications to look at those things. No? So in the Philippines, we have rice being monitored by the DA Rice, so Philippine Rice Institute under the Department of Agriculture. And then we have the sugarcane areas being monitored by the Sugar Regulatory Administration, which is an attached agency of the Department of Agriculture. But if you look at corn, then there's no particular special agency. It's being monitored by the Department of Agriculture to a program, but they don't utilize heavily, say, earth observation data sets. So PhilSA is starting to work with the Department of Agriculture, and this corn mapping will also be included maybe in the land cover mapping, showing specific major crops in the Philippines. And there are also need to look at onion areas or garlic producing areas, as well as potato. So these are more difficult, even more difficult to map and monitor compared to rice, sugarcane, and corn. So through this project of the datos, the SACA, so we are working with the Department of Agriculture. And this is basically, MOA was recently signed with the Department of Agriculture and Fisheries Engineering, and it will be expanded maybe to include other bureaus under the Department of Agriculture in order to look at farm-to-market rows, mapping of corn and onion in selected areas. So the Philippines is undertaking a major program on expanding and extending and improving the conditions of various farm-to-market rows in the country. And we are requested by the Department of Agriculture in order to look at or map these areas and also monitor the condition of these two various very high resolution satellite imagery and possibly other methodologies, including drone mapping. So what we can see here are just comparison of what we can see from planet and also from SkySat. No? The progression or the development of various farm to market roads in Ilocos Sur or the northern Philippines. This is another example in Ilocos Sur in San Juan. So using planet. No? So there are of course issues with the occlusion and so on, but later we will look at, of course, other data sets, including Sentinel-1 or maybe even ALOS to compensate or to work on more data. For the corn mapping effort, we are utilizing the dynamic time warping, analyzing the signature, particularly NDVI or maybe later on some other indices, and doing the reconstruction by applying some filtering method to remove the effects or minimize the effect of clouds and map the corn and forage crops in certain areas. So we are concerned with, say, mapping how many hectares are planted with, for example, corn or rice. But in terms of stages, we have to look at the full vegetative stage, the flowering stage, and the harvestable stage, no, in order to provide those information to the Department of Agriculture. The same goes with our onion mapping effort, which is practically more difficult, but we are looking at many other things. But these areas are also impacted by another problem. You have various diseases or infestation affecting these areas. In onion, you have the armyworm. In the sugarcane, you have many insects that are affecting. So you have to contend with also not just mapping those crop areas, but also to look at those infestation, early warning, early detection of those diseases. No? So that's a challenge in our basically agricultural sector. No? Recently, we're also discussing with the Bureau of Fisheries and Aquatic Resources, because of course, in terms of food security, it's not just covering the agriculture or the livestock and so on, but we also have to look at the fisheries, no, both the mariculture, aquaculture, as well as those natural caught in the wild. No? And for that, it is very important to map the different habitats. The benthic habitat mapping is very important. So this is an example of habitat mapping from, I think, Planet, utilizing random forests with different classes. This area is Boracay, so primarily this is fern. And we are also doing some seagrass mapping. So what we do is we would like to estimate the percentage of seagrass in a particular, say, Sentinel 10 by 10 meter pixel. So we are working on various, say, drone data sets, capturing them and mapping the percentages or the extent of coverage of seagrasses at ultra high resolution, maybe just a few centimeters, and utilizing those data in a model to map eventually the seagrass percent cover from Sentinel to using Google Earth Engine in various parts of the Philippines and later to expand this to the entire country. We are also utilizing hyperspectral imagery for say mapping the different benthic habitats. So say in this case, we have the seagrass percentage cover around the Santiago Island in the Bolinao, Pangasinan. So this, in terms of, say, within a 30 by 30 pixel, we can estimate the percentage of seagrass, percentage of corals, and also sand in those particular areas. So, of course, we have to ensure that there will be users of these particular data sets. So we partner with agencies such as the A or the Department of Environment and Natural Resources. In this case, we are looking at monitoring reforestation areas. We are looking at the Natural Resource Accounting Program, including coastal marine ecosystems, water quality, and ocean productivity. No? And currently, this program is ongoing. So this is a partnership between the OSD, the Space Agency, and European Space Agency for the COPIL program. So under this particular program, there will be the establishment of the Copernicus Mirror site to eventually to serve the entire country, the Philippines, and eventually the entire Southeast Asian region, making available the Copernicus satellite images readily available to many users. And there will be three pilot projects, in the Philippines. One is focusing on land cover mapping, including forests and major crops. There are also projects on benthic habitat mapping and monitoring, and the ground motion monitoring using primarily Sentinel-1. So this will be initially done in several pilot areas throughout the country, but it will be scaled up to cover the entire country and produce data sets, at least yearly, and of course maybe more frequent for the ground motion monitoring. There will be also capacity building activity, providing scholarship and fellowships to Filipinos. And I think I have a few more minutes. So currently, we have a directive from our president on developing a system to make this data, satellite data and data products easily accessible and utilizable by the different agencies as well as the citizens. So we are developing this system, the Field Space Plus, which is a system of systems to enable such institutions and citizens to access and utilize space data. It will also cover the development of the data field eventually. And part of that action plan are these 8 action points. Now. So we have to know the landscape. We have to really know what's out there. For example, what are the needs of the local government units? Increase their absorptive capacity for geospatial information. Increase the private sector engagement. Build and maintain infrastructure. Develop policy frameworks. Strengthen our RDI. Establish the network of networks and enhance the system of feedbacks. This is particularly what we have to do at the moment because we have been distributing a lot of data to local government units on floods, on resources, and so on, but we still have to ask them if they were able to use it, or if they were able, if they need more data, they need more capacity building in order to utilize such information. So we are undertaking this FILSA integrated network for space-enabled action towards sustainability. We've been to these yellow parts, the northern part. This is Mindoro. This is Panay Island in Aklan, and we have the Palawan. Usually, the way we go there or prioritize depending on the situation. There was an oil spill in Mindoro, so maybe just a few months after that, then we went there to look at the situation as well as collaborate with the local government units. In this area, we are looking at one big area called the Mount Matalingahan Protected Landscape in tandem with the various government institutions. And in March, we'll be going to Zamboanga City to link up with the agencies within the Sambasulta region. And we've been to, this one should be yellow, we've been to Davao now. So what we do is we introduce our agency, the projects that we do, and we distribute the data and we do some initial training on the ODK mapping. And later on, we will invite them to the Philippine Space Agency for more detailed capacity building. Currently, we are developing this space data dashboard. So this is where we will be putting our data products so that the LGUs and government agencies can access them and do some basic analytical stuff. Maybe comparing changes or looking at trends for various, data products such as land cover or even mangrove cover and so on. Recently, we have produced the mangrove cover of the Philippines for 2023. This will undergo validation, extensive validation in partnership with regional offices of our Department of Environment and Natural Resources and local government units and non-governmental organizations working on the environment. So again, this is work in development. So there will be a lot more data, and this will be launched formally in March 2024. Here we are seeing, I think, maybe floods. The red areas are flooded areas comparing one time against another. And there are also layers on mangroves and eventually on blue carbon, above ground biomass, and those kind of stuff. I think that's all for my presentation. So these are our contacts, and thank you very much for listening.
Thank you very much. Any question from the floor for the doctor?
I would like to mention that, of course, we received the invitation from TASA to have us have collaboration under the Mecoteco scheme, and we will be happy to work with TASA on the, yeah. Of course, we work.
I have question to Tasa. We have not get invitation from Tasa neighbor, so you're gonna invite us very soon. Just kidding, okay?
I just want to say we will try our best.
Yeah, let's try our best. I think the deadline is February 22 for the like the capsule proposal.
Nobody talking about JAXA. Sorry.
No. Just already have the good agreement with this, and actually today is just coming from the sign up amendment, extending our collaboration for this anyway. And also that we know that our president is just visiting the TASA and to have the discussion. And of course, in the Philippines,
With the ALOS.
yeah,
For the
we just
discussion.
starting to the agreement. And but I have a question about how to collect in soil moisture, which you mentioned, because in the you only mentioned in the because it's a not you didn't mention how to collect.
Yeah. The work on drought is actually being done by the Earth Science Space Mission and Monitoring Division. So that is one way to examine I mean to improve the drought index by incorporating the soil moisture. I think they plan to use AMSAR E and also deploy some maybe soil moisture meter. I'm not sure about the exact plan, but maybe something like that.
I have a question then for all the space agency up to now. What about other institute or other agencies that not really space agency? How do they cooperate or get to work with you guys? That's also because it seemed to be like within the space agency only. So like I don't know, like from ISGC, if they would like to work too, then now you already working together. And then for Hydroinformatics Institute, or even the Asia Hydroinformatics Center, something like that. Is it the way to try to cooperate together, or even to from India, or so Tokyo, or Nepal, or New Caledonia? So, or Muffin, I don't know. Is a way to cooperate with that.
Yeah, well, actually, we already have it's a collaboration agreement with NAF, Japan, and also the ASEAN offices, and even say China, you know, China. Therefore, we don't have any barrier to how to collaborating with the end user because the stakeholder to the collaboration with stakeholder is one important thing. And the question is how to collaborate not only for the governmental agency but also private sector. That is the current way and the Dr. Park want to promote in the sales. Yeah, but we JAXA is strategy implementation team chair. Yeah, so we can cooperate with them.
I'm from the Ministry of Agriculture and Forestry and Fisheries of Japan. And about the collaboration with JAXA, there's no direct collaboration, but I hear that there is some collaboration with, between MAFI and JAXA via NICT. So although there's, we don't hear much about JAXA, but there are some contact with NICT. That's it.
I mean, like some other application that would be utilize the data since we have a lot of data already up to now. So just want to expand it.
Of course, APN is always open and welcome for such collaborations. At least in our disaster mitigation working group, we've been extended to the application of the space data and also the Earth observation-based applications. Yeah.
Any further? Okay.
Thank you, Chai. I'm Sundar Sharma from Nepal. Currently, I am working at the National Disaster Risk Reduction and Management Authority. At the same time, I'm coordinating UNDRA Regional South Asia Wildland Fire Network. This is the first time I'm participating in this meeting. Very interesting, and I'm learning a lot. Currently, you know that Nepal is suffering from the current earthquake in western part of Nepal, in Jajarkot earthquake, and we are in the reconstruction phase. We may need some support from the space agencies to map the hazard and all multi-hazard risk and vulnerability mapping. Thank you.
Okay, any further question? If not, we have a break for half an hour. So go enjoy the break and then come back at 10:30, I believe. No, 10 o'clock, 10 o'clock, 10 o'clock. Okay, you still listening to me. Okay. Yeah, 11 o'clock. So 10 o'clock, please, 25 minutes. Huh? Oh. Yeah, different time zone. Yeah, okay. Well, you could.